Okay, so we're continuing along the lines of the topics of quadratics and parabolas, and we're moving on to looking at what a parabola actually is. So by the end of this video, you'll know the key features of a parabola, such as its roots, which are also called the x-intercept, the y-intercept, the turning point, and the axis of symmetry, and you'll be able to state whether a parabola has a maximum or minimum turning point. Okay, and these features that we're discussing here are essential for when we want to sketch parabolas, and we want to do that as quickly and as efficiently as possible. Okay, so consider the function f of x equals x squared minus 2x minus 8. Plot this function and state its roots, turning point, and whether it's a maximum or minimum, and axis of symmetry. Okay, so if I go and get my pen, so we've got the function f of x is equal to x squared minus 2x minus 8, and I want to generate some values that I can substitute in and plot. So let's go with 0. Okay, so 0 into f of x would give me 0 squared minus 2 times 0, which is 0, minus 8. So that one is coming out at negative 8, and I can plot 0, negative 8. Okay, so the next value I'm going to go for is 1. So I've got 1 squared, which is 1, minus 2 times 1, which is 2. So 1 minus 2, which is negative 1, minus 8, which is negative 9. So 1, negative 9. Oh, I'm not going to get that one. Okay, right, let's try negative 1. So negative 1 squared, which is 1, minus 2 times negative 1, which is plus 2. So we're going to have 1 plus 2, which is 3, minus 8, which is negative 5. So negative 1, 1, 2, 3, 4, 5. Okay, right, so I need to edit the location of all of this just slightly. Let's select and move this up here. So that needed to be negative 1 at 5. That needs to be 0, 8. And that needs to be 1, negative 9. Okay, right. Now we can keep going. Sort of that. Hopefully this works now. Okay, so let's go 2. So if we put in, so that gave us negative 9, that gave us negative 5. So let's go 2. 2 squared, which is 4, minus 2 times 2, which is 0. So 4 minus 4 is 0, minus 8, negative 8. Okay, so then I'm going to go negative 2. So I would get 4 minus 2 times negative 2, which would give me 4 again. But this time it will be positive 4, so I've got 8 plus 8. Sorry. 4 plus 4, which is 0. No, 4 plus 4, which is 8, minus 8, which is 0. Okay, right, and then I'm going to take, sorry, I put that in the wrong place, that should be here. And then I'm going to take, just as my last point, I'm going to take 3. So I want the eraser first. Okay, so the last point I'm going to substitute in is 3. I'm just going to stick it in there. So what did we get for 2? For 2 we got negative 8, and for negative 2 we got 0. Okay, so let's substitute in 3. 3 squared is 9, minus 2 times 3, which is 6. So 9 minus 6 is 3, minus another 8, negative 5. And hopefully you can kind of see what's going on here. And if I put in my next point, if I put in 4 squared minus 2 times 4 minus 8, it's going to come out at 0. And what I have here is now the same shape on both sides of what we call the turning point, and I'll join this all up, and I promise it will probably won't be neat. And this function is what we call a parabola. Okay, it's a symmetrical shape. It has a turning point and an axis of symmetry. It has roots, and we're going to go through all of those bits now, right? So I'm going to change the colour of my pen. I'm going to go green. Okay, so the first thing we have to figure out is its roots. The roots and the x-intercept are the same thing. Here's your x-axis. Where are you cutting the x-axis? You're cutting it here and here. So your roots happen here or here, and they are x equals -2 and x equals 4. And those are your roots, okay? So the roots are in green. Okay, right, let's change colour now. Let's go to red. Okay, we want the turning point. Well, hopefully you can see you started with a graph that was heading in a downwards direction. It came to this point here and then started going upwards again. So this here is what we call our turning point, and it is at the point 1, -9. Okay, and now we have to state whether it's a maximum or minimum. Okay, now maximum or minimum is really easy to figure out. Is it the highest part of your graph or the lowest part of your graph? And here it's lowest. Your graph isn't going to get any lower than that, so then it is a minimum turning point. Okay, so the turning point stuff is in red. Okay, right, and then we have our axis of symmetry. Okay, and let me change colour of pen again, and let's go blue. Okay, your axis of symmetry happens when your graph starts to turn on itself, because that's when you've got points matching up again, and your axis of symmetry happens here. Your axis of symmetry is a completely vertical line, okay, and any vertical line we know is always x equals, and here the vertical line on the x-axis is x equals 1. And those are your key points of a parabola. We will use the roots, the turning point, and whether it's maximum or minimum to sketch parabolas later, because we don't want to be doing all of this every single time. We have a much quicker, much more efficient way to do it, and that will be in 2 videos time. Okay, so now we want to consider the function f of x is 9 minus x squared. We want to plot the function and state the roots, turning point, whether it's maximum or minimum, axis, and symmetry. Right, so let's get my purple pen back again. So this time we've got x, and f of x, and again I'm going to go in at 0 again. 9 minus 0 is 9, so 2, 4, 6, 8, so 9 right up there. Okay, right, so 0, 9. Next thing I'm going to go for is 1. So 9 minus 1 is 8, so I got 8 here. Okay, hopefully you're going to have figured out already that -1 is also going to give you 8. Okay, right, let's look at what happens when x is 2. So we get 9 minus 4, because 2 squared is 4, so we get 5, and we'll get the same thing for -2. And then the last thing we're going to check, just so we can finish this off, is 3. 9 minus 3 squared, so 9 minus 9 is 0, so 3, 0, we're coming out here. Okay, so I've got myself another parabola now. You can see it's completely symmetrical. Connecting up the points, I apologise. Please make sure your graphs look a lot better than this. Okay, there's the parabola. Now we want to work out the roots. So the roots I put in green pen last time, so let's go with that again. So the roots happen here and here, and they happen at x equals -3 and at x equals 3. 2 roots, 2 x-intercepts where we're crossing the x-axis twice. Okay, so what were we were red pen next. And what we're trying to figure out now is turning point and whether it's maximum or minimum. So your turning point is happening at 0, 9. Is it the top part of your graph or the bottom? Well, it's the top, so therefore it's a maximum turning point. Okay, so there's the information on the turning point at the top of the graph, so then it's maximum. And then the last thing, which if I remember correctly, we put in blue pen, is the axis of symmetry. Well, here you go, this is where it is symmetrical. So that is when x is 0. Hopefully, between this example and the last example, you have noticed that your axis of symmetry is always the x coordinate of your turning point. Here we have the turning point of 1, -9, and our axis of symmetry was x is 1. Here we have a turning point of 0, 9, and our axis of symmetry is x equals 0. We will be looking again at sketching quadratics in a further video with the aims of doing it much quicker. Again, just focusing on those key things. Once you have those key things, you can sketch, and you can sketch quickly and efficiently and accurately. The last thing we're missing is the y-intercept. If we go back and look, you can find the y-intercept. I'll put it in black. So where does your graph cut the y-axis? Our graph cuts the y-axis here, so our y-intercept is -8. And then here, luckily, our y-intercept is also our y-axis is on the y-axis is on the turning point, so our y-intercept is 9. Okay, so let's just check when we go back to the first video. Do we know the key features of a parabola, such as roots, x or the x-intercept, y-intercept, turning point, and axis of symmetry? Well, I hope so now. And be able to state whether a parabola has a maximum or minimum turning point, then yeah, hopefully we've covered both of those things and we're quite clear on what those things are.